Alright, so we're going to pick up right here where we left off on this video. We just finished working with node D. We still have 3 members left to work with. We've been working from left to right so far, so I'm just going to go ahead and keep doing that. We've fully analyzed node E. We have fully analyzed node D. Let's go ahead and see what we've got left at node C that we can get these next 2 members since they both work on node C. So C has, from our last calculation, it has 50 going down. From this calculation, we have 50 going to the right. And then we've got some unknown force there, and we have that travels over to B. And then we have some force here that goes down to A, and we know that this angle is the 33.69. So that's everything we've got at C. Let's set up our 2 force equations and see what we've got. So the sum of all forces at C with respect to X must equal 0. So that would give us, since BC is purely horizontal, that gives us F of BC plus CE is purely horizontal. This 50 is a horizontal force, and it's going to the right. That makes it positive, so plus 50. Plus, we've also got whatever force is occurring here between A and C. It also has a horizontal element. So we've got force of AC with respect to X, and those 3 added together equal 0. As happened in an earlier node calculation, we see that we have 2 unknowns in that equation, and so we're going to leave that equation for now, and we are going to switch over and work with the y in hopes that the y only has 1 unknown associated with it. So let's see how this works out for us. We take the sum forces C with respect to y. We've got this 50 going down, so that is going to be negative 50. And then the only other force that we have is this force being applied between C and A. So that would be plus the force of AC with respect to y must equal 0. The force of AC with respect to y will be the overall force of AC. Since we are working with y, it is the sine of the angle it is applied at, which is 33.69. And we add the 50 to both sides. That equals 50. So our overall force of AC is going to be 50 divided by the sine of 33.69, which we find to be 90.14. And it is a positive value. We are working with y, so it needs to go up. So this is coming up. That means that when we put it here, the arrow is coming into C. So in the middle of this beam, opposite arrows, this arrow is coming back. That arrow is going in, so that is 90.14 in compression. And then that arrow is going to come back into there, and there is that node. This, now that we have F of AC, we can come back into here and replace that value in. So we're going to erase the y part. Right, now that we have that F of AC of 90.14 as our overall F of AC, we can use that with the cosine to calculate to solve this and calculate for F of BC now. So let's go ahead and do that. So I'll get rid of this. Working with our x's now, we have F of BC plus 50 plus F of AC. And with respect to x, that arrow is going to the right. That is a positive direction. So that would be plus 90 33.14. Since we are working with x, cosine of 33.69 equals 0. Solving for f of BC, we get that f of BC equals, so our f of BC is negative 125. That is, so negative means our arrow is going in that direction. So when we get into the member, we are coming out. And that 125, since they are pushing out, that is 125 tension. We have one member left, that is member AB, and it does not really matter at all which one we use because we've only got one unknown left. So let's just go ahead and work with B. So at B, I have 50 going up. I have 125 going to the left. I have 125 going to the right, and then I have this straight up and down one. Quite simply, the 125s, notice we canceled, we went all the way through there, and in the end, that 125 coming in there is purely horizontal, and it is counteracting that 125 that we have right there. So after all that calculation, we got back to that 125 at the very beginning, and we see that those two counteract each other. That's good news. That's proof that we've done it right. This 50 going straight up, the only thing we could do is have 50 coming straight down off of it. So we pull that 50 coming down. And so that 50 is in tension. And that is the end of the problem. So like I said before, I would try and do that problem multiple times until you can get the right answer on your own. There are two more practice problems on the same sheet that this problem is on. Enjoy your time working with trusses. I hope this helped, and I will see you in class.